My name is Jimmy Bogard. You can find me on Twitter at @jbogard. And this presentation and all the code with it will be on my GitHub at github.com/jbogard. And a lot of what I'll be covering today is some of my experiences over the past few years of dealing with failures in distributed systems. Some of the stuff I'll be covering today will include a lot of the improvements in this area in observability with .NET 5. So we've been able to provide see some observability in .NET-based systems, but really what we're seeing in the last year or two are some kind of leaps and bounds improvements in some of the standards that the broader community is putting out there, as well as .NET Core, .NET 5 support for a lot of the standards. So first, let's talk a little bit about distributed tracing and kind of why we need it. So for a lot of the applications I deal with, when I deal with a failure in them, it's just like one single running application by itself. And when something goes wrong in that application, we get this stack trace, which can tell us exactly where in the code that failure occurred. But it's not just like what line of code that failure occurred. It also includes all of the code that led up to that individual failure. So we can see the trace of calls within a single running application. So for a single application, this works great, right? I can say, well, this method called that method called that method. It kind of tells you how it led up to that individual failure. Now things become quite a bit more complicated when I start to have more than one system and application that makes up my overall system. So in this case, they've got like an API that talks to some other backend worker service, and that worker services uses messaging or something to talk to some other worker service. And if something goes wrong, like way down the dependency chain, how do I know what the initial call from the outward API led up to that individual error? So if I did something like logs, for example, let's say I had each of these applications doing logging. Well, it'd be really hard to understand how those different logs like kind of fit back together again to be able to give that sort of stack trace that we had from just a single running application. So what we want is that the same kind of stack trace view that we had when we have a single application, that this time we want to see it across all these different applications. And so this is what's known as distributed tracing. Now, when I have these different calls going through each other, I have to somehow link those different calls together. So in a single stack trace, it's fairly simple for us to say, well, this method called that method, and the host framework can kind of remember where I was in the stack to be able to give you a nice stack trace at the end. But when I have all these different applications calling each other, that's not so easy to get. And so what a lot of folks that were building distributed systems, kind of the Twitters of the world and the LinkedIns of the world, they recognized this problem pretty early on, maybe because they were like moving fast and breaking stuff all the time, but they needed to figure out, okay, something broke way down here. How do I know how the other calls actually work to be able to lead up to this error that we saw way at the bottom? And so that leads us into distributed tracing. And the general idea behind distributed tracing is to be able to provide enough information in each of the calls as it flows through the system to be able to connect these puzzle pieces back together by something that is kind of gathering all these different logs from all these different places. And the solutions wind up being, I'd say not simple, but in hindsight, fairly obvious, because what we're trying to build is basically a graph of calls from one system to the next. So if system A calls system B, then I have to have some way to say that there's a unique call that was made from system A to system B. So when system B does any logging, it says, and by the way, this system B execution is related to this other one over here. And so the solution to this problem is to use a graph. And the graph has IDs that relate and identify individual calls. So as a call flows through the system, it will identify each individual call and pass along its ID to the next call, so that something can look at these IDs and these parent IDs and say, okay, it looks like what I have here is a graph of calls of all these things putting together. So the end result is something similar to something like your Git history, where I have an ID of a call and then also include the parent ID of that call. And then by putting the IDs and the parent IDs together, I can build an entire graph of all the different calls that went together. So some of the bigger social networking sites that were building these kinds of systems did more and more work with them, and eventually started to open source them to allow other folks to be able to get this kind of insight and visibility into their distributed systems. And one of the big examples of that is Zipkin. Zipkin is an open source tool from, gosh, I think it was, I'm going to be wrong about this. I'm going to say Twitter, but that's probably wrong. And the Zifkin tool introduced some standardization around how do we flow the context of identifiers from one point to the next. And this is known as the B3 header standard. And the B3 header standard says you can have these if you just in your calls, in your network calls, as you make one call to the next, if you just include these headers as part of it, something listening in on that traffic can pick those special headers up and then build out an overall graph of all these different things. Now, as more and more tracing tools came on the market, each of them had their own little flavor of this information as it flowed through the system. They had their own kind of special headers and things like that. So if you've used something like Azure Monitor App Insights, if you ever looked at the headers inside of there, you probably saw some like really weird looking ones related to App Insights. And they're doing effectively the same kind of thing as putting these special headers in calls and requests so that something can put these pieces back together again and identify unique requests as they flow through. So folks got together and said, right, now we have 5 different standards for describing these tracing headers that they flow through the system. So what we really need is a new standard to standardize all the other ones. And unlike previous efforts, which just resulted in like yet another standard, this one actually has a lot of backing from the industry to be able to really try to solve a lot of problems that all these individual ones solve individual pieces of. So this is what's known as the W3C Trace Context Standard. And W3C Trace Context is a standard that defines how do we relate individual calls to each other, and they do this through another standard header known as the trace parent header. And the other big piece that .NET Core uses to be able to kind of capture what is the current running action that is happening is known as the activity API. And this is from a NuGet package, the system.diagnostics sources package that allows individual applications to be able to track what is the current running thing that is executing and have a way to flow the parent information from one individual action to the next. So this standard from W3C was moved to recommendation this year. And starting with .NET Core 3.0, you had the ability to use this standard in your applications. Now this standard, the W3C standard, really was targeted for HTTP-based traffic. There are some clauses in there saying, here's how you can do tracing for gRPC-based traffic, basically making the headers as small as possible. But if I'm doing to other kinds of traffic, let's say I'm using messaging with AMQP, RabbitMQ, whatever it might be, what can we use there? So the general recommendation there from the W3C is just adopt the same standard headers as you generate these messages, and then something can then look at those standard headers to be able to report back to some kind of tracing tool. Now, if I just have all these headers flowing through the system, being able to link all these different requests together, that's not enough to be able to kind of see what's going on. So the next thing we need is actually something that can visualize these traces, something that's listening in to the traffic inside of my systems, looking at these headers, and then being able to show somebody, okay, here's, based on this run request, here's how it flowed through the system. So one good example of that is, of course, Zipkin. Zipkin not only provides a way to standardize kind of the headers as requests flow through the system, but also a way for individual applications to report those traces. So as things are executing, you can have like background threads and things like that that are notifying Zipkin, I've just received this trace information with this trace ID, with this parent ID, with this extra information, and then it's gathering that information so that then you as a SRE or developer can go look at those traces and be able to see all the graphic calls as they go together. There's a few other great tools out there. Jaeger's another great example of a tool. App Insights is another great tool as well. Jaeger and Zipkin are really dedicated towards tracing, where Azure Monitor and App Insights are more like performance oriented, but they can all do distributed traces. And so now we have another problem. So the W3C trace context standard was really defining the horizontal arrows in this picture. That is, as one system communicates with another, how do we identify the connection between those two calls? And that's that W3C trace context standard, to have that header flow through all the different requests. But then there's all these downward arrows that have to report the traces to something. And so these individual systems, Jaeger, Zipkin, App Insights, they all have special APIs that you have to call if you want to report traces to them. So typically what you have to do is go to NuGet, look for the thing you're doing, like HTTP client, and then look for the tracing tool that you're trying to use, Jaeger, Zipkin, Prometheus, App Insights, whatever. And hopefully there's a connection between those two, that there's something that can report HTTP client traces to Jaeger, Zipkin, App Insights, whatever. And so a lot of the major ones out there have those. But myself, I work on a lot of different projects and a lot of different clients. It becomes a kind of horrible matrix of support of all these different ways that you can communicate headers, all these different ways to report traces, and it becomes a bit of a mess. So the next piece of the puzzle is to try to standardize on the down arrows. That is, standardize the definition of what these traces should look like and how to report on them as well. And that effort is the OpenTelemetry effort. OpenTelemetry is a joint open source effort between a lot of the folks that build these sort of tools, like the Jaegers, the Zipkins, the App Insights of the world, banding together and saying, instead of us having to constantly have to build new packages for all these different kinds of things out there, what if we can agree on a kind of a common standard of the different primitives in the observability world and the ways you can report on them? Because there's only so many ways you can really define what a span of activities looks like, or what a log looks like, or what metrics looks like. And so the OpenTelemetry effort is really trying to bring all those together and saying, right, this is our standard way of looking at things. And then that way, if I have client applications and different ways of reporting, just talking to OpenTelemetry, then it's just a matter of someone building the OpenTelemetry exporters out to those different individual Zipkin Jaegers of the world. Or if those different tracing tools support the OpenTelemetry APIs out of the box, then there's really nothing we need to do. If I need to move from App Insights to something else, then it's just a matter of me changing a URL as opposed to having to change the infrastructure for all my different projects to be able to get that fixed and updated. So let's look at some demos here. I want to look at first just some activity basics of the APIs behind tracing and spans and the W3C standards inside of .NET 5. And then we'll look at how we can actually visualize these through some of the new .NET 5 things released, I guess, like a month ago. All right, so let's look first at some activity basics. So I've got a really, really dumb application here. Just a simple console application. Let me go ahead and bump up the font. There we go. And so this is just a single application. There's not calling out to anything else. And right now it's just one single function calling into another. Now, of course, if something goes wrong in this function down here, there's an exception gets thrown in that other method, then the exception would include a stack trace that says, okay, I've got this thing and this other thing, and then I'm good to go there. Now, if this method has additional things I want to learn about it, like, I don't know, like the method parameters being passed in or something like that, then typically we'd have some kind of logging that occurs as part of this. Now, it can become very tricky when I have methods calling other methods to be able to put those different pieces together and to be able to observe and see what's actually going on behind this method. And so that's where the System Diagnostics API comes into play. So let's go ahead and pop open the dependencies of the packages here. And so what I've done is I've pulled in this package here, system.diagnostics.diagnostics source. This package includes all of the diagnostics APIs for tracing and metrics for .NET-based applications. And the interesting thing about this package is actually distributed out of band from .NET Core, .NET 5. So any application that wants to target and use this kind of tracing only needs to pull in this package. It's not locked to a specific .NET version. So even if I've got, I think this one supports all the way back to like .NET 4.5, I can even have .NET 4.5 based applications taking advantage of the new tracing things coming with this package. So what is in this package? So if I have something that I want to identify as an action that I'm interested in with respect to tracing, then what I'll be doing is defining an activity. So say var activity equals new activity. And that's not good enough. I actually have to give it a name, because this is how this activity is going to be identified when I'm looking at traces flowing through my system. So this activity represents the concept in other tracing tools of a span. And in fact, this is completely analogous to the OpenTelemetry concept of spans. They didn't change the name because it's been around for, I don't know, almost 10 years. So rather than try to change this to be the OpenTelemetry standard, they said, let's just conform this thing to be what the OpenTelemetry span concept is. So this represents a distinct span of activity that I would be interested in reporting on in a tracing tool. As part of this activity, I can start it. And down here, I can stop it. And when I stop it, I will have interesting things like the duration of this activity. So if this activity is calling out to a web service or SQL or something else over the network, then this duration can tell me how long that other activity took to do. Now, in this other thing I have going on, I can do the same kind of thing where I create a new activity, and give it an appropriate name, do something, and do the similar kind of thing, activity.start, activity.stop. Okay, so let's go ahead and run this. I'm gonna put a breakpoint right here, and I'll put a breakpoint, that's good enough. So one of the challenges we have with traces is that we have to identify individual actions or activities versus other activities. So that means our activity is actually going to have an identifier that distinguishes this specific instance of running this application and starting this activity versus something else. So inside of my activity, it will have an ID. Right now, the ID is null because I have not yet started this activity. So once I go right past it, blip, and I go look at my activity, we'll actually see the activity has an ID. Now the ID is long. It's got 00 dash a bunch of stuff, but starting with .NET 5, this ID format is actually the new W3C trace context format. So for .NET 5 based applications, we don't actually have to do anything to start using this new standard for our activities and spans. Now, eventually when we get to like web service calls and other network calls, this is the ID that's going to be put on top of that outgoing header so that subsequent activities on receiving applications can pull on that ID and be able to link those two activities together. So first, let's go to inside of here. I've got another activity. I knew it up, and then let's look at it real quick. Nothing inside of it. There's something else down here though, which is a parent and a parent ID. So now we have a concept of linking between a child activity and the parent activity. And once I start it, its ID gets populated, but notice the parent and parent ID are populated as well. So I have the parent ID, which looks like a lot of this is the same. So this first part is actually known as the trace identifier. And this next one is known as the span identifier. So it uniquely identifies this thing, and this other set of numbers and letters links the overall trace. But how did this work? I didn't pass the activity in. I didn't pass it through as a parameter. Well, it turns out that the currently executing activity is being held on a special property activity.current. And that activity.current is a thread local static property that any code can look at to say, what is my currently executing activity? So I've got code way down somewhere else, and I need to push out to the current activity ID in a header, or even look at it for any kind of information. That's where I can go from. Now, so that's all well and good, but what about when I'm in a distributed world where I don't have activity.current? So when I call one API to the next, how do I then link all those things together? So the next piece is pulling in another thing from .NET 5 to be able to kind of link all these things together. And that is using var activity. Actually, I've put it in my toolbox, so I'll just go ahead and drag it over here. And these are known as, oops, I totally screwed that up. Let's not highlight anything. There we go. Gonna make a lot of space for it. There we go. Okay. This is known as an activity listener. And the other thing we'll need is an activity source. Read-only activity source goes new. And the name will be console app. Yep, that's good enough. Okay, so in order to actually get traces out into something that's going to be taking that information and then doing something with it, then we have to have a way for code way deep down, whenever it starts and stops activities, to let something know that activities are starting and stopping. And so that's really where this activity source and activity listener come into play. So down here, where I'm saying activity starts, it's creating a new activity, instead of me using just newing it up activity, instead what I'll do is I'll say using var activity equals start activity. Now the name is going to be main. And there we go. Actually, don't even need to have that there. That'll do the same thing down here. I'll replace this stuff that manually creates the activity and starts and stops it, and then instead just do something. Instead, I'll use this activity source and listener. Okay, so what do we just do here? We added this activity source as a means to start activities. And so down here, instead of me newing an app activity, instead I will use the activity source to say, start this activity named main. The return value of this is an activity. And that's the thing I can use to then go add additional information to the activity if I want to. And the same thing down here. And it's at the end of it, activities are disposable. So it actually will stop the activity as part of this using block. So the next thing I need is, now that I have a source for the activities, something needs to know when activities start and stop. So if I've got some infrastructure code way down in the deep of like SQL or Mongo or whatever it might be, starting and stopping activities whenever these interesting things are going on, something needs to be notified, like, oh, I'm calling into a database, I'm calling into an HTTP client, and I need to then record that activity somewhere else, or just do something with it. And so that is the activity listener API. These two things, the activity source and the activity listener, are the new things with the .NET 5 release, with the 5.0 release of the diagnostics source package. So this activity listener has properties first to say, should I listen to this thing or not? So in this case, I can look at the, what is this saying? This is the activity source. So that's this thing over here. I can say, well, I want to look at the sources that are from this name or from that name or whatever. So I can say, you know, only pull the ones that name equals console app. That way I am only pulling out the activity starts and stops from that specific name. In this case, I'm just saying, just go ahead and pull them on it. Just do them all. I also need to tell the activity listener whether or not I'm actually sampling this one or not. So in a high throughput or lots of calls going on, I don't want to necessarily sample every single time something starts and stops. So if I got, you know, thousands and tens of thousands of requests per second, this just listening in to see what's going on may add a lot of overhead. So I might want to say like only sample every 10th one or something like that if I'm looking for performance-based stuff. This one I'm saying just go ahead and say do all of them. And then we get these callbacks for whenever an activity starts and stops. And so what I'm doing here is just outputting the activity information, saying here's the parent ID, here's the activity ID when it stops, here's the parent ID and the activity ID when it starts. So now, when I run this application, I've got listening code completely separate from the actual logic doing the activity raising and the actual like running part of the application. And so this listening in of activities, this is what all came in from this is what all came in from the OpenTelemetry standard. All this sort of API about, well, you should have a thing called should listen to and start and stop. A lot of this came from OpenTelemetry about here's how a lot of different applications should do this. So if I'm going to a node-based application, the API should look very, very similar, if not identical. All right, you run this and we'll look at the output. All right, so in my log that I've just console write-lined, I can see that it included the first activity that had no parent ID and this parent ID with the start. And the next one started, so it included the current ID and the parent ID over there. Then it actually did the work, and then finally stopped the activities in the reverse order that they stopped. So I have stop and stop. So with this activity source, activity listeners, that provides a means of something to listen into these activities and then I'll report them out to some kind of tracing tool. So that is going to be the next demo that we look at, looking at OpenTelemetry. So we pop open to a more interesting distributed system, or I should say a distributed system. And so this application, what I've got is a web application with a simple API. But in that API, I will do something a little bit more complicated than just outputting to the screen. Instead, what I'm going to be using is messaging via RabbitMQ to send a message to a back-end child process. This one will use a direct one-way send, and the other one will actually use a publish. So one's a fan-out kind of message, and one is just sending a message directly to something. So as part of this, I need to make sure that whenever I send that message, that actually include the header on that message on the way out, so that the thing that's listening to all the tracing information will be able to get that header information, the parent ID, and be able to link everything back together again. Now, when I send this message, I will send it to a backend worker service. So this one is a say something. This is actually a somewhat more complicated process in that it will kick off a complex saga, which will coordinate activities between different backend systems. This one sends a message over to another child worker service over here that will say, go do this other thing, talk to MongoDB to do some stuff, and get information back out again. So it's trying to be as complicated as it can for 3 applications to be able to accomplish some kind of activity. Now, in order to get these things to actually be able to report distributed tracing, there's a couple packages that need to pull in. The first one is OpenTelemetry, and that is this right here. And so what this is doing is providing a way to send out reported activities to some kind of exporters. And I've actually pulled in a couple of exporters from NuGet as well, Zipkin and Jaeger. The next thing I need to have is something that is listening into those activities so they can be reported out through these exporters. Then the ones I pulled in so far include ASP.NET Core, so that's incoming requests. This one is SQL client, so anything talks to SQL. A couple others I've got include, let's see, I've got MongoDB being able to report events as well. I've also got SQL in one of these, or no, HTTP client as well. So this one also includes HTTP client traffic. So something talking HTTP clients, incoming or outgoing, RabbitMQ, SQL client, and Mongo, all in one single running application. And it's all configured inside of my startup. So I'll start with saying, add OpenTelemetry tracing. And so this is very similar to what you may have used with like services.add_app_insights, but instead of tying myself in my tracing tools to one specific implementation, instead I'm tying myself to the OpenTelemetry standard. And you can kind of think of this as similarly in your applications that you don't want to necessarily couple yourself directly to some individual logging provider like Serolog or Log4net. Instead, you want to have just kind of the standard API that all of your stuff uses, which would be the Microsoft extensions logging. So you're just using iLogger all over the place. That's exactly what this is saying as well, is don't plug into any individual proprietary way of doing tracing. Instead, use the standard OpenTelemetry way of doing things, which is going to be using the activity API. I want to tell it to pull in instrumentation for ASP.NET Core and SQL clients. Now these, because these have already been published for years and years, what this instrumentation is only going to do is bridge the older way of reporting traces, which use another API called Diagnostic Listener, to the new way of doing things, which is using activity sources and activity listeners. But I don't have to do that. If I want to just create new activity sources, then I can say just add source, give it the name of the source, whatever that might be. And as long as that name matches up to the name of the activity source, then any start and stop activities that get used to that source will just magically show up in my tracing tool. There's nothing that I need to do because OpenTelemetry has standardized on using activities for the spans and reporting. I'm using in-service bus for messaging. So the only thing this is doing is it's just calling add source with that special name. So it's just kind of a very little shim on top of just the standard everything uses activities. Now the next thing I'm telling it is, okay, now that you've gathered the instrumentation together, where should you export these items to? And so that's the next two pieces, is a Zipkin exporter to be able to say, go ahead and publish out to Zipkin, or Jaeger. Now, if they're using the standard OpenTelemetry APIs, which the plans are for these two to be able to adopt that, then the only thing I would change is going to be the URL of what to report those spans to. And that's it. And maybe even that won't change if it shares the same URL. So with all that in place, let me go ahead and run this and see what I see. Okay, so I have 3 running applications, 1 for the kind of web API and 2 for the backend just message processing services. And it's not as important like what those things are doing behind the scenes, other than they're talking to databases, talking to HTTP, doing all sorts of stuff. I got this, of course, the Swagger UI to be able to do something. So I'm going to go ahead and kick this off and say, let's go ahead and try it out. And say, hello world. I'll hit execute. And that one didn't do much, right? And the controller, all I did was send a message, but behind the scenes, it's doing a whole lot. So if I actually pull up the web application, we should see the results of that. Because eventually the message actually does make it back all the way to the web application, but through RabbitMQ as opposed to whatever. Okay, so there's a bunch of stuff, but at the very bottom, you can see received back at you, hello world, and it's something, and it's basically calling different services and applications to be able to gather information together to finally receive a message back to the front end here. But this right here came through RabbitMQ as opposed to HTTP. Okay, so I just had a complicated set of calls get made that made it eventually back to the web application. Let's go ahead and pop open our tracing tool. Now this one, I've got two open. One is Zipkin and one is Jaeger. And if I just go ahead and hit search for the past, let's see, 15 minutes, aha, we see some traces come up. I can do the same thing in the Jaeger UI as well, where I go back and search, find traces, and there we had just one from a minute ago. All right, so if I click on this one, now we'll see all the web of calls that were made throughout this application. So I didn't go through every single call and every single method that get executed as part of this, but it is pretty complicated. We start off with the web application execution, and the only thing that does is turn around and send a message via RabbitMQ. But at this point, this is where a kind of normal tracing stops. Like, yeah, I've sent this message out the door, and the only trace I have is just a single web request, and that's it. But for this, we'll actually have a lot more because we're including the tracing information for all the subsequent processes as well. So this worker service receives the message and does some additional processing. It sends a message to another process to be able to call an API. I call the API to get some more information. That calls into a database. And so as part of this, we can actually see here is the database statement that was executed as part of that individual statement. This one actually did a couple things in parallel. So it did one process and another send over here. So it continues on where it says process, send, process. Oh, here's one that's calling MongoDB. So this one I can actually see the MongoDB statement that was executed as well. Does some other stuff. Finally, it receives the message back, and finally at the very end, we have the web application. It was the last end of the chain that said, okay, here's the message I finally received, back at you, whatever, and all this other stuff. So looking at, let's do this one more time. I'm gonna set a breakpoint right. Actually, let's do this first. I'm going to stop this. I'm just going to run the individual web application by itself. Debug, start new instance. And then what we'll do is pop open RabbitMQ to see oops, 15, localhost 15672, RabbitMQ. Guest. Okay, so back in my Swagger UI, let's go ahead and send a message. And now I'm not running any of the child applications. So I see a response body of whatever. Now let's go look at RabbitMQ. And over in our child worker service, we actually see a message sitting in its queue. And if we go look at this, they bump up get messages, and let's look at one of these things, and we'll notice on here, aha, there's that exciting trace parent identifier. So we see that when I made the initial call, it created this activity ID. When I made a subsequent call and had a message go out the door, it included that trace parent header. So that, go ahead and stop this. Now I'm going to set a breakpoint in my worker service, that initial handler that receives that first message. And what I'll do is I'll look at the current activity at that point in time, and what we'll see is that it's actually receiving that message and been given the parent ID from that initial, from that message that went over the wire. All right. Oh, I deleted the message. I shouldn't have done that. Anyway, so inside of here, we have some middleware that is going to take that header off of the wire and then set the parent ID of this current activity. So that way I've been able to not necessarily have a current activity that's in memory, but said, okay, I don't have a current activity in memory. Let me go ahead and pull the parent ID from this external source, which would be the header of the incoming request. Okay, all that in place. This again. Now, one of the challenges we'll run into with distributed tracing is once I have like a lot of traffic going on and a lot of traces showing up, and it can be pretty hard to distinguish like one message from the other. So if I execute this a few times, execute. Right, so then now I have a lot of traces going on. So if I go back over to my tracing tool, go back and look. Now I've got quite a few traces that got executed. So you can kind of like, well, let's go ahead and search by start time. Maybe that'll help. But now it becomes this kind of needle in the haystack problem that how do I distinguish one individual trace from another? Well, there's a couple different ways of doing this. One is for us to go over to the initial code that starts to kick things off and say, how do we provide some additional context information so I can distinguish this one individual request from another? Well, a simple way of doing that would be just to say, what I'll do is I'll say activity.current.add tag. And so adding a tag allows us to put on additional information about this span or activity that we can get from whatever kind of currently is being executed. So I can say, well, this is really the command ID dot toString, okay? So tags are a way to provide that additional information of an individual request. And over in our tracing tool, we go look at one of these spans. Over here, we have a bunch of tags. Now these tags come from those activities. And so one of the other things that OpenTelemetry has done is standardized about what are the expected tags for different kinds of processes you would have. So HTTP should have these tags, messaging should have these tags, database stuff should have these tags, and that's all been kind of standardized so that there's some consistency in my different tags. Well, I as a developer can also add additional information as part of that. But there's a problem. Sometimes those tags don't make it all the way out to the reporting tools, nor do they make it like all the way down to like whatever is reporting on those tags as well. So there's another emerging standard out there, which has actually been supported since .NET Core 3, and this is known as the W3C baggage standard. So what I'm going to do is, instead of adding a tag, which only exists for that one activity, I'm going to add something known as baggage. And baggage is interesting in that baggage will also get flowed to child activities. Tags are only for that one activity, but when I have an activity as a child of another one, its baggage will automatically be pushed down to that other one as well. But the next piece, which is really interesting, is baggage will also flow throughout my requests. So in addition to having trace context, having the trace parent header that flows through, baggage also gets flowed through every single call as well, which means that subsequent operations can then report on the baggage that's being flowed to it. So something like this operation ID, what I'll do is that instead of adding it as a tag, I'll add it as baggage. And then using those trace listeners, what I will do is I will say, I'm going to, for every single activity that exists out there, when that activity stops, I'm going to copy all of the baggage over to tags so that when that tag is actually reported out to the tracing clients, all the tags actually get pushed out there. And this is because tracing tools don't automatically record baggage. They just, today they basically use it for tracing tools to kind of key in on pieces of information. What I'm telling it to do is go ahead and turn around and go ahead and report that information out to the tracing tool on its tags. And so I'll do this in each one of my applications. So just when it starts up, I'll just say, go ahead and, do that. And down here, I will do that as well. And what we're trying to do here is increase what's known as cardinality. That is, we got a lot of data that's not really related to each other, and it's really difficult to search for the thing that we're interested in. But if we were to increase the cardinality by including some critical information, which is in this case the operation ID of the thing happening, and this could be anything. It could be the user ID, it could be the environment that it's in, anything that I want to search on in these tracing tools, I can put on top of this as baggage and then report it out on a tag. So let's run this one last time. And now when I execute the operation in Swagger, out of that will return the ID of the operation. Execute. It's down here, the response body is the ID of the operation. And now in my tracing tool, instead of just seeing a bazillion traces that are hard to understand, it's like so many of them, instead, I'm going to say I want to search on a tag called operation ID equal to that GUID. And now when I search, aha, I only get the one that I was interested in. So now when I click into it and I look at all these different operations over here, aha, operation ID has now made it into every single one of my traces and spans. They're all the way down. Any one I click will have that operation ID as part of it. So that's great. You can imagine the kinds of things you'd want to search on, like users, maybe it's some kind of business identifier, workflow identifier, batch ID, cart ID. You can put that in the baggage and it will flow to every single request. So it's like those things you like to put in your log files that is additional context. This baggage is that additional context you can search on when trying to really nail down, like, user reported an error, and now you can search on it and be able to get that exact one that you're interested in. So for more information, you can go to my GitHub. There's a presentations repository, so all the code that you see here, I even have a more complicated example on there as well. You can find on there. Otherwise, I thank you all very much for joining. I hope you all have a great rest of the thing.
Thank you so much. So we've got some questions.
Yeah, we got some questions. Maybe some of them you a bit tackled towards the end. So for instance, there's one that, is there a tool that can collect all telemetry information, logs, traces, metrics, and correlate them?
So is there a tool that can correlate all those things together? Yes, none of them are free though. So if your company is in need of that thing, they're probably making enough money to be able to buy these sort of tools, but some good ones out there. App Insights, of course, does this. So you can go like click on a thing, it'll see the traces, you can see the logs as part of that. Honeycomb is another great tool as well that some of my clients are using. But Splunk is also getting into this game as well. So if your company is using Splunk, they've actually purchased another tracing and metrics tool, and they're planning to bring those together with OpenTelemetry as a thing that kind of binds it all together.
So Jimmy, money are not a problem, are not an issue. So,
it's all in the name of science, right?
Right.
The other question.
The other question is about tags and baggage. Having to do that, I'm just paraphrasing here, having to do that hack with the listener to flow tags sounds like a mess. Are there plans to properly support these and make them consistent?
Yeah, so that's a great question. And I posed that to some of the standards team just to understand like what's the end goal with this. And that's one that's a little bit fuzzier because some of the tracing tools do use baggage a lot, but they use it for really for purposes of the tracing tool itself, as opposed to kind of user provided baggage. So they try to make it much more generic to say, you can throw anything you want in there, and then it's up to you to determine how you want to report on that information. So for our teams, we saw that as a great opportunity to say, let's go ahead and just report on that baggage. And as far as automatically doing that, It's really up to the exporters themselves to say, let's go ahead and push that out. The pushback I've heard so far is PII, personally identifiable information. They don't necessarily want to include like user IDs in there and have like, what's the European thing you'll have to care about that I don't have to care about? GPDR,
GDPR, yeah.
Yeah, the right to be forgotten. So that user ID is something that they're like, maybe we don't want to put that in by default. So it's kind of a hack as it is today, but it's not terrible, I guess.
So Jimmy, thank you so much for being with us today.
Yeah, thanks for having me.
To have you back at Codecamp online or in person next year.
Yeah, it's been awesome. Thanks a lot, like Soren said, and yeah, before you dropped out, let's just wish you a Merry Christmas and Happy New Year.
Happy New Year.
Yeah, thanks for having me.
At least formally this year will end, and then we continue our activities and learning process next year. Thanks a lot, Jimmy.
Thanks.
See you, Jimmy.